All right, since I know everyone is ready here, so hey, Big Mac, you ready? Earbud, is that away? Okay, all right. So, we're ready? You ready? Yeah. Class?
Yes.
Thank you. All right, so we're going to go through and do the inscribed angles. So, today we are working on page number, what page is this?
12. 14.
15.
15 is the notes.
Yeah. 15 is the notes, 14 is the homework. Okay, odds and evens all the time. Odd numbers are going to always be on the right hand side, and that's going to be my notes. Again, I will show you there is a reason to my madness. Okay, so when you open up the notebook, you have your notes staring at you as you're working on the homework. So you have practice right there on how to see there to there. I know you might play with your phone right now, are you? Uh-huh, yeah, that's not your phone, right? No, you wouldn't do that, would you? It's almost like it's on YouTube right now. I have proof.
No.
Yes.
Not YouTube.
Yes.
No.
Okay. Yes.
No.
Yes.
No.
Yes. Yes. Okay, this creature doesn't believe me. Let me see where we at. YouTube. Okay. So this is me yelling at a student, and I have proof of it. So where's the geometry one? Oh, there it is, geometry. That's me yelling at you, and it's going on YouTube later.
No,
So when I call your parents, I'm gonna be like, hey, playing with their phone doesn't do any work.
Me?
Yes, you.
No.
I have proof right now. They can even hear your voice on YouTube right now.
Play it.
Okay. I know, I can't mess up my video right now. Okay. I'll play it later. So remember that. Okay? Yes, thank you. You're not playing with your phone during my lesson. So inscribed angle. The word inscribed means on the inside. Is an angle whose vertex is on a circle and whose common side chords of the circle. So this over here is touching the inside. Yes? Yours has it. Are you on the other side? Huh? So, sorry about that. So, let's go through. Okay, right here. Intercepted arc consists of endpoints that lie on sides of an inscribed angle. All the points of the circle between them a chord or arc subtends of an angle if its endpoints lie on the sides of the angle. So, see this right here? Go. Those are the chords. That is the inscribed angle. So, inscribed angle right here. These are the chords where they actually touch right there. The formula that goes along with this is my inscribed angle is 1/2 of my arc. This is my arc. On the outside is AC. Inscribed angle would be over here at B. That would be 1/2 of that value. Always. It's always going to be 1/2. So if this arc A to C is 50, angle B over here would be what? 25. Half of 50, right? Yes? Okay. It's that easy. It really is. So to find the values, that's all you're going to do. Now looking at this one right here, we have two examples. Okay, find the measure below and y. Oh, that's over here. Okay, watch this. This arc from here to here is how much? 76, right? I know this is not super crazy. Okay, it's not a trick question. It's almost like telling someone to put their earbuds away and they still have them in. But you ain't heard it from me. I ain't want to gossip.
Alright.
So, you ready? If this is 76, this angle right here over at A should be half of 76. What is half of 76? 38. I take 76 and divide by 2. 76 divided by 2 is going to give me 38. So what am I going to write in there? 38, right?
Yeah.
So that's going to be 38 degrees. Okay.
That's it?
That's part of it. That's part of it. Okay. Now, I'm going to change colors on this one. Now, for the next one, see this right here?
Yeah.
My two endpoints are here and here. And it says this angle here at B is going to be 135. This one, B, is the inscribed angle. That one is the inscribed angle. So I know that the inscribed angle was half of the arc. The arc is the measurement around the outside where they go together. So if the inscribed angle is 135, the arc should be twice that. What is twice 135? 270. Very good. So right here, the arc from A all the way over here down to C is going to be 270. So now, let's say this. Measure of angle DAE. DAE, we said was 38 degrees. Measure of the arc ADC, A to D to C, was 270 degrees. Hopefully you guys, easy enough, right? Okay. So we'll keep going. Now, on example 2, my interior angle is 128. Okay, this is called a central angle. What do we know about the central angle and the arc that goes with it? They're what? Perfect, good job. They are congruent. So since this is a central angle, it's right here at the center of the circle. My central angle is congruent to my arc. So that means right here, my x value is going to be how much? 128 degrees. Because they are the same. They are congruent. They have the same measure. Okay, so now let's go ahead and switch it up a bit. So now this one is looking for y. So from here to here is 128. Now let's go do the inscribed, which is touching over here on the inside of the circle, over at y. And we know that the inscribed angle should be half. Very good. The inside angle should be half. It's almost like a very good thing to write down in your notes, that the inscribed angle should be half of the outside. So if my outside is 128, the inside is?
64.
Very good. So y equals 64 degrees. Super easy, right?
Yeah.
Okay. So we have some more formulas to go with this. Okay, that all the ones are going to be the same. And this will make sense here in a little bit. I'll explain why. Now, I have this angle right here. So K is the inscribed angle of LM, isn't it? Say yes.
Yes.
Yes, it is the inscribed angle of LM. J is the inscribed angle of what? LM, very good, right? Of LM. So, do they both have the same angle that they're inscribed from?
Yeah.
Yes, they're both inscribed from the same thing. So since they're both inscribed from the same thing, that means that both inscribed angles need to be the same. They need to be congruent. That's what that whole thing is said up there a minute ago. It was the corollary of that. If they have the same inscribed arc, the inscribed angles are going to be the same. So what I'm going to do to solve for this, I know that these two are congruent, so I could set them equal. 5b minus 7 is equal to 3b. And we're going to do a little bit of algebra here. Okay, do a little bit of algebra. Let's see if you can solve for it right now. You can use it if you need it.
It's 3/5.
Okay, bless you, I think. So, bless you, I think. I'm going to minus 5b to both sides.
Oh, bless you.
Negative 7 is equal to
2.
negative 2b. Yep. And then now I'm going to divide both sides by negative 2. B equals not 14, 3.5, because it's 7 divided by 2. It's half of 7, right? Half of 7. So divided by 2 is half of it. So that is 3.5.
Bingo.
Okay. So now it's not asking for solving for B. It says find the measure of the angle. So let's go ahead and plug it in. I'm going to plug it in over here at angle K. So that's going to be 3 times 3.5 is going to give me 3 times 3.5. I heard it.
It's 10/5.
Yeah, there we go. 10.5. So this angle right here is 10.5. That one is the inscribed angle. That's the inscribed angle. Now the arc that goes with that, I know has to be how much?
3/5. 10.
21. Why 21?
Because it's 10.5 times 2.
Times 2, right? It's twice what my inscribed angle is. So it's going to be this number times 2. So this arc, LM, is LJM. Now, if I want to find LJM, this is why this one's actually, yeah, let's do this one. So from L to J,
It's okay.
all the way over to M.
Oh, we just solved it.
All the way around. So what type of arc is that? It has 3 letters. So that should be a key there. Isn't this a major arc? Okay, a major arc is more than 180, isn't it? So I'm not looking for that little piece of LM. I'm looking for everything else, right? So if I'm looking for everything else, the whole circle is how much?
360.
Very good. Did you write that down? Do you know that a circle is 360 degrees? And if you didn't, you're going to write this down, that 360 degrees. Every circle is 360 degrees. But since I'm looking for everything else besides LM, I'm going to go 360 minus 21, which is going to give me 339 degrees as my answer.
How do we go 21?
Why'd you put 21?
No. How do we got 21?
How did I get 21? Okay, so did you get that my angle K over here, did you get that that's 10.5? Did you get this?
Yeah.
Okay, so to get over here, remember, this one is the inscribed. This one opposite over here should be 2 times, okay? So 2 times 10.5 is 21. That's where I get that piece is 21. All right, question still? Yes, go ahead. We're about ready to do something else, so you really want to be gone for the rest of this. Uh-huh. So I'm gonna pause right here.
Are we back with more video?
Okay, here we go. So we're gonna continue this right here. So I know that you guys are all paying attention. We're gonna take a look at example 5. My notes look slightly different than yours. Okay, mine, I just had to spread mine out so I could show work. So, an inscribed angle subtends of a semicircle if and only if the angle is a right angle. So, if this line right here is the diameter all the way across the circle through the center, that means that this is 180 degrees. That's 180 degrees. Okay. By definition, if this is the arc, the inscribed angle that goes with that would be way over here. Half of 180 is 90. That's why this is a right angle. That little box right there implies that that is a right angle. Now, here's the problem we're doing. This is my diameter. It is cutting through the center of the circle all the way through. That is going to be there. So if that is my diameter, goes to the center, the arc from W to Y is 180. So that means that over here at Z is 90. That little box right there means it's 90. So we're going to do the math to go along with it to find the value of A. I know that 5A plus 20 is equal to the angle itself, which is 90. Okay, let's do some algebra. What am I going to do to that 20? Minus, I'm going to subtract 20 to both sides. So 5A is 70. Now to get A by itself, divide everything, right?
Yeah.
Divide everything by 5. A is 70 divided by 5 is 14. There we go. And the problem said find the value of A. We found out what A is. And my last thing has to do with other types of circles, which are going to be polygons. This is a quadrilateral. The word quad means 4. Quad means 4. So a quadrilateral has 4 sides, it has 4 angles. So on this quadrilateral with 4 sides and 4 angles, it says right here, okay, that its opposite angles are supplementary. The word supplementary means they add up to 180. So this is why we got the thing on the homework that is just like this. So if they add up to 180, so D and B together add up to 180. A and C together need to add up to 180. Okay, here we go. This one, we look, this is going to be at an angle right here. It is going this way, and it's going this way. So the opposite of that angle, J, would be using the same endpoints, which is H and K, use those same endpoints. So that means that it's going to be over here at G, uses those same two endpoints. Now, being equal to 180 supplementary, that means that that plus that equals 180. So I'm going to write that out like that. Mathematically, I'm going to write 6b plus 20, I know, I'm trying to finish, plus 25 equals 180.
Don't you have to do both sides?
You will, but it's going to be 9b plus 45 equals 180 minus 45. 9b is 135. Divide by 9. B is 15? Yeah. So, there we go. I finished just in time here for you. Make sure you guys all like, share, and subscribe. I want you guys getting onto Canvas. Get onto Canvas this weekend. I will have something special on there for you.
Hold on,